Hey guys, today we're going to talk about atomic structure. So you should be able to name the subatomic particles that make up an atom. You should know where they are located, and you should be able to use atomic and mass numbers to distinguish between atoms. So let's first talk about the structure. So there are three subatomic particles that make up an atom. Electrons are the negatively charged subatomic particles, these blue ones down here that orbit the nucleus of the atom. They are extremely small. We consider them to have 0 AMU, or 0 atomic mass units. Protons are the positively charged subatomic particles that you find in the nucleus. They are green here. They're larger than an electron. We say that they have 1 atomic mass unit, or 1 AMU. The last ones, also located in the nucleus, these red ones here, are neutrons, or neutral neutrons. So these are the subatomic particles that do not have a charge. They are the same size as a proton, so we consider them to have 1 atomic mass unit. So let's get a little bit further into this. You might have noticed in the graphic that there's space in between the nucleus and those electrons. So the nucleus is composed of those protons and neutrons. It is the heaviest part of the atom, because remember, those are what really hold the mass. We call them 1 AMU each. And it's also the most dense place. Electrons orbit that nucleus kind of a lot like a planet orbits a sun. There's a lot of space in between the planet and that sun, right? Same thing here with the electrons. There's a lot of space between the electrons and the nucleus. So let's talk about atomic number. So when we talk about atomic number, we're talking about elements. They have different numbers of what we call protons. So those positive subatomic particles. So each element is unique because it has a very particular number of protons. No same element has different numbers of protons. Protons are unique to that element. So carbon always has 6 protons. So the atomic number of an element is the number of protons in the nucleus of that particular element. And so we'll talk a lot about atomic number because it's what shows up on the periodic table, and we're going to take a look at one of those next. The next thing that you might see on a periodic table is called the mass number. So the mass number is the combination of protons and neutrons in a particular atom. So we remember those are the things that hold mass. So when we add the two of those things together, we get the mass. If you want to know the number of neutrons, you're going to take the mass number and you're going to subtract the atomic number from it. So all we really need to know about an element is its number of protons, that's its atomic number, and we need to know information about its mass so we can find out how many neutrons it has. So let's take a look at a periodic table here. We're going to zoom into the key. Most periodic tables will have the atomic number. It'll either be the first one you see or it'll be the largest one on the table. And so this tells us the number of protons in the element of sodium. So all sodium atoms have 11 protons. Next is the element symbol. So this is how we recognize what element it is. The element name in this case is sodium. And then we have a weighted mass. So we're going to talk about that on the next slide because this isn't a whole number, which is kind of weird, right? We can't have portions of a neutron. So if we were to think of this as a whole number, 23, our mass would be 23. If we had 11 protons, that means we must have 12 neutrons. All right, let's take a look at isotopes. And this is where the average atomic mass comes into play. So isotopes of an element have different numbers of neutrons. So we know that all elements, if they are, say, sodium, have 11 protons, but they could have different numbers of neutrons, which would change their mass, right? They could have different mass then. Here's an example for hydrogen. Hydrogen 1 is just a proton. Hydrogen 2 is a proton and a neutron, so there's different number of neutrons between 1 and 2, right? Hydrogen 3 is a proton plus 2 neutrons. So in this case, now we have a difference of 2 neutrons compared to 1. When we see these three in their naturally occurring samples, we would calculate a weighted average mass of the atoms by taking the percentage of each and then determining what the total, what the naturally occurring or that weighted average mass would be, which we're going to learn about those calculations later. But the number that's listed on our periodic table doesn't represent necessarily the element or the particular atom you're looking at. It might represent the total weighted average of a naturally occurring sample that might have a little bit of percentage of each of these in it. All right, isotope symbols, sometimes known as atomic symbols, is going to be something we're looking at today. So we're going to determine what A, Z, and X are represented by. If we look at this example here, we see Li. This is something we would see on the periodic table. This is lithium. Our element symbol for lithium is Li. When we look at lithium, we'll see that it has 3 protons in each of these examples. So this 3 down below, this Z, represents the atomic number or the number of protons. Up above, we have a number that changes. So if we count the subatomic particles in the nucleus, we have 6 here, 7 here, and 8 here. And we'll see that this up here in this top left-hand corner is actually telling us the mass of that particular atom. So A represents our mass, Z our atomic number, and X represents our element symbol. Occasionally, we will have electrical charge represented in here as well. So we'll see some sort of charge up in this right-hand corner. When an element is charged, we call it an ion. So atoms become charged when they either gain or lose electrons. If something is negatively charged, that means it has more electrons, or those negative charges, than it does protons, which are positively charged. If something's positively charged, that means that it has more protons, so more positive charge, than electron, negative charge. That's our last slide. I hope this was helpful in understanding a little bit more about atomic